In this video we are going to talk about the angle between two vectors in space. We will use exactly the same formula as we used in vectors in two-dimensional plane, which is the cosine of theta between the vectors, the angle between the vectors, is equal to u dot v divided by the product of the magnitudes of the vectors u and v. So, as we did in vectors in the coordinate plane, we can modify this formula such as we can go through that theta equals cosine inverse of what we have here as the calculations, u dot v divided by the products of the magnitudes of u and v. Instead of going through this, you can directly go through this formula, so you can directly find the angle. Now let's see an example. Here it says find the angle theta between u and v to the nearest tenth of a degree, which means 1 decimal place, if u and v are given as follows in component form. Now here is our formula. Now we are going to find the angle between those vectors. So it will be like, okay, theta equals cosine inverse of, well, u dot v is, that's right, 3, 2, minus 1, dot, minus 4, 3, minus 2, divided by, well, the magnitude of u is 3 squared plus 2 squared plus minus 1 squared in square root times the magnitude of v, which is minus 4 squared plus 3 squared plus minus 2 squared, again in a square root. So of course we have to simplify all these expressions, which will be like the cosine inverse of, say, 3 times minus 4 plus 2 times 3 plus minus 1 times minus 2. So let's write the values. 3 times minus 4 is minus 12 plus 2 times 3 is 6 plus minus 1 times minus 2 is 2 over, when we do the calculations here, this is 9, this is 4, and this is 1. So when we add them, we get 9 plus 4, 13, 13 plus 1, 14. So this is actually square root of 14 times, and this one we have 16, 9 and 4, which will give me the sum to be 16 plus 9, 25, 25 plus 4, 29. So further simplifying, we will have the cosine inverse of, when we do the addition here, it will be minus 12 plus 6, which is minus 6, plus 2, minus 4 over, well, square root of, if you'd like, you can multiply, saying that 406. Okay, now is the time to go through the inverse cosine. So you will approximately find 101.5 degrees. This is the angle between the vectors u and v. So if we want to visualize, this is the graph of those vectors, and this is the angle in between, as you see here. Okay, now is your turn. You can find the angle between these two vectors. Okay, no panic, just because you have the linear combination of these vectors. You're going to write them in component form, and you know how. Okay, so be careful that you're missing the unit vector j here, so you will write the component form accordingly. So you will find the angle between those two vectors. Stop the video now and 5 seconds after that you will see the answer.